that you are assigned is the 9-5 number 1 homework. And that'll be due on Wednesday. That's your last homework assignment. I'll have to go back and see if there's any back
So
here.
there's no
Because
chapter.
I don't have any more up here.
There's no chapter 9 yet.
So we're getting ready for our chapter 9.
What is the chapter 9 assessment?
So here we go. We need to get through these problems and then we can look at the rest of them on the review sheet. So what does this little squiggle mean? What am I supposed to be doing here?
Every number between 1 and 160.
I'm adding, and the numbers I'm adding, I find by plugging in 1, and then 2, and then 3, and so on and so on and so on. So when I plug in 1, I get 3. And when I plug in 2, I get 5. 3 is 7, and I really don't want to keep going. The last one will be 321. So I'm going to plug in every number from 1 to 160, right? And I need to add all these up, right? So I always like to write out a few of them here because that kind of tells me what I'm dealing with. What kind of a series is this? Arithmetic. So I'm going to look at my formula list and I'm going to pull this one. This is my arithmetic sum. Sigma always means sum. How many am I adding up? If I start with 1 and go all the way to 160, how many is that? 160. Oh, please don't mess that up. Don't overthink it. Oh my gosh, 1, 2, 3, 4. Yeah, for 160. So I got 160 over 2. I've already figured out the first term and the last term. So this problem is done except for the calculator. So everybody should get 25,920. Okay? Next question. Oliver does 2 problems on the first day of school, 15 on the second day, 28 on the third day, and so on. List the first 5 terms. Well, I've already done 3 of them. What's the next one? 41. And the one after that will be 54. So if you did that, then you can answer the second part. Find the common difference. Well, the common difference is 13. Write the explicit formula. So the explicit formula is this one for an arithmetic sequence. And we have to plug in what we know. So the nth term will be the first term plus the difference times n minus 1. So this is the formula for every arithmetic sequence in the world. This is the formula if the first term is 2 and the common difference is 13. So we'll clean this up a little bit, just doing our basic arithmetic. Looks like 13n minus 11. And that is our explicit formula. That will find any term we want, including the 180th. How many problems will he do on the 180th day? This formula will tell you that. So the 180th term is 13 times 180 minus 11. So he's going to do 2,329 problems. He likes math. How many problems will he have done during same problem? Are 4 and 5 the same problem?
No,
No, what's different?
the fifth one, or the fifth, problem 5, whatever, is every day added up.
Every day added up. So I'm gonna have to find the sum of 180 terms. So whatever those 180 terms are, I'm gonna find the sum. So that, it's arithmetic, so that formula says 180 over 2 times the first one, which is 2, plus the 180th, which I just figured out. And that will be the answer to question 5. Looks like, oh gosh, 209,790 problems is how many he's doing altogether. Okay? All right, so I can turn that off now. We don't need that anymore. Those are done. All right, so now what do we need to do? Okay, so look at your sheet. Let's do some review problems here. This is the whole chapter. Then, so what do we got? He's got a question. Look at the whole review sheet. Lots of problems. Here we go. All right, I'll just start at the beginning. We'll get through whatever we get through. How many ways can we arrange the letters of the word "You are my friends"? What's the first thing I need to do? I see how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 letters. So I'm starting with 15 factorial. Then what do I need to do?
Find that multiples.
Yeah, we're gonna need to look at, well, I see a couple of R's right off the bat, so I'll take those out. And there's a couple of E's. There's a couple of Y's. If I had 3 of something, I would be dividing by 3 factorial, but so far I've only had 2. Did I get everything?
Yeah.
Is that okay?
R-E-Y. Yeah.
Yeah. All right, so I'm gonna go to my calculator and I'm gonna type in 15 factorial. And then I'm gonna, that is a very big number. And then I'm going to divide by all of this. Now, 2 factorial is a simple little number. What does 2 factorial mean? 2. So in the bottom, isn't this just 2 times 2 times 2?
Yeah.
So if you don't want to type in all those factorials, you can just divide by 8. Or you can put in all the factorials. It's completely up to you, whatever makes sense. But the answer is big. Even with the duplicates, it's still a very big number. Right? How many ways can a captain and an assistant captain be chosen from a team of 10?
P.
What?
P.
Definite P. 10 people choosing 2 at a time. Order matters because their jobs are different.
Specific.
So that is 90. Now look at number 3. 2 co-captains are being chosen. That's gonna be a C. And that I think is 45. You type that in on your calculator. So, when do we use P and C? If order matters, it's a P. When does order matter? If you're giving away different prizes, if you have different jobs, basically if stuff is different, you're going to have order matter. And otherwise it doesn't. Okay. How many ways can 5 people be seated in a row? 5 factorial. 5 factorial for 5 people seated in a row. Jump down to number 6. How many ways can 6 kids be seated in a circle? 5 factorial. Same answer. Because when you arrange things in a circle, circles have no beginnings and no ends. So when you arrange them in a circle, it's 1 less. 1 less factorial. So 6 people in a row, 6 factorial. 6 people in a circle, 5 factorial. Got it? Got it? And our answer is 120. Not 5 factorial, which is, I know that's 120, but you got a calculator, you work it out. Okay, now back to number 5. I have 5 algebra and 6 geometry. How many ways can I arrange them if they're all different? If these are all different books, so think of it like a word and they're all different letters. How many ways could that be done? 11 factorial. I do not know what that is, but that is another very big number. So 39 million? Is that okay with everybody? Now, does it matter that some are geometry and some are algebra? No. Just like boys and girls. 11 people, 11 factorial. The books are all different, but they have to stay with their own subject. So now I'm going to organize my shelf. So I'm going to have all my algebras together and all my geometries together.
5 factorial, is it times or plus 6 factorial?
It has a 5 factorial and a 6 factorial in it. They're being arranged together, so it's going to be a multiply. But there's something else. There's something else that's in this problem.
Over 2 factorial.
What?
Over 2 factorial.
Not over 2 factorial, times 2 factorial. And here's why. First of all, we only divide when we have duplicates. Okay? These aren't duplicates. Here's why. If somebody gives me this pile of books and says, okay, all the algebra's got to be together, all the geometry's got to be together, what's the first thing I'm going to do? I'm going to get all the algebras sorted out and say, okay, here they are. These all got to stay together. So it's like having an imaginary rubber band around those algebra books. And then I have a rubber band around the geometry books because they have to stay together. So how many things am I really arranging? Big picture wise, I'm only arranging 2 things. A clump of geometry and a clump of algebra. That's this right here. This is my bundles. Now, when I tie that rubber band around my algebra books, that could happen in lots of different ways, right? And likewise with the geometries. So this is the number of bundles, and then this is each bundle. So that is the answer to the problem. Which, if I typed it in right, is 172,800. All right, so that was B. Okay, C. The geometry books are all identical. Now, C goes back to the original problem. I have all these books I'm going to put on a shelf. How many ways can I arrange them if the geometries are all identical? What's your thought on that?
Does it not even matter then? That like do you not do a factorial since they're all the same?
Actually, you do have to do a factorial because they can be interspersed. So it's like the repeat letters. The first thing we do is count up how many letters we have. How many books do we have? And that can be arranged 11 factorial ways. But 6 of those books are identical. So it's like having 6 M's in the word. What am I going to do? Divide. You do not take the factorials out of the original, or the duplicates out of the original arrangement, Katie. They get divided out after you have arranged. Do not try anything wacky with that. You have to type it in. $55,440. And finally, the geometry books are identical and must be kept together. So think about your books now. You've got these 5 algebra books. And this bundle of geometry books that has to stay together. So they got a rubber band around them. How many things are we really arranging then? 6? 1, 2, 3, 4, 5, 6. How many ways can 6 things be arranged in a row? 6 factorial. But remember when we tied a string around those? Those right there can be arranged 6 factorial ways. But they're all the same. So basically those two cancel each other out. I think that's what you were getting at, Katie, earlier. But that's it. So this is the 6 things that I am arranging. This is my bundle of geometries. There's 6 in there. And 6 geometry books can be arranged 6 factorial ways, except they're all the same. So I have to divide by that 6 factorial. So my answer is 720. Okay. How many ways can 4 red, 6 green that are duplicates, and 2 yellow be arranged to make a necklace? All right, what's your thought? What are you thinking? What's the first thing you're doing? I hope.
See how many there are.
Seeing how many there are, count up your beads. So how many do we have? 12? We have 12 beads. Right? But we're making them into a necklace. What does that mean?
Circle.
It's a circle, so we're not gonna start with 12 factorial, we're gonna start with 11 factorial. And then we're gonna have to divide by 6 factorial because there are 6 beads that are identical, just like 6 M's in a word or 6 geometry books. And does anybody remember, there's one more little piece to this. Does anybody happen to remember what it is? Divide by 2. And Beatrice, do you remember why I divide by 2?
There's like only one way that faces forward.
Exactly. That's a good way of thinking about it. If I were to make this necklace and you're looking at it like this, if I take it off, I am looking at the same necklace, but it looks different because I'm looking at the other side of it. Those are not 2 different necklaces. So I have to divide out the second one. Yep, that's exactly right. And that's just a 2, not a 2 factorial, even though they are the same number. All right, so I got got 27,720. Is that right? You think? Mm-hmm. All right, that was 7. How about 8? Find a third, that should say term. There's another mistake, that should say term. Find the third term of this. So think about that for a second. If we FOILed that out 10 times, there would be a whole bunch of terms, right? A whole bunch of pieces of that answer. We want the third one in the list. Do you remember anything about the third one or any term in general?
Oh,
Well, there's going to be a coefficient, a number. There's going to be a 5x, and there's going to be a negative 3y. Every term of this problem is going to have those 3 components. Every term. The number's going to be different, and the exponents are going to be different depending on which term you're at, but every one is going to have those things.
X
Okay.
is to the 8th, y is to the 2nd. The x is to the 8th, and y is to the 2nd.
Okay, so in terms of the variables, we know if we FOIL this out, in the first term, it would be an x to the 10th. Does that make sense to everybody? And then the second term would be x to the 9th. So the third term is going to have x to the 8th. We want the third term. These exponents must add up to that. So if that's an 8, this is going to be a 2. Now I need my coefficient. There's already going to be numbers in the problem here, but I need my coefficient. Somebody said the triangle. That you could get the coefficient from Pascal's triangle. Which row would you need? The 10th.
That's a lot of rows.
That's a lot of rows, but you could do that. You could absolutely build it out to the 10th. And you wouldn't necessarily have to build the whole triangle. Aren't you just interested in this side over here?
Yeah.
Yeah. So you need to get down to the 10th row, third number in. Now, does anybody remember another way to do that? With these big ones, I prefer to do combinations. The 10th row, you can write out the triangle. 100% write it out if you want. But the 10th row numbers will be these. These are the numbers in the 10th row. I'm not gonna write them all out, but they're all the way down to 10C0. So those are the numbers in the 10th row. 10C10, 10C9. The numbers in the 11th row are 11C11, 11C10, and so on. So this is the coefficient I want. So now I've figured out my coefficient either with the triangle, and you'll have an actual number there. And then I figured out my exponents, and now I'm ready to simplify. So, gonna be big. So I have 45, oh Lord, times 390,625 times 9. Remember, the exponents go with the numbers also. So that's 5 to the 8th. That's 3 to the 2nd. So I'm going to multiply all those together. And my term is 158203125 x to the 8th y squared.
Huh.
So this is a perfect example. Could you FOIL this out 10 times and get your answer? Yes, but it's going to take you a week. Right? All right, so the next one's a little long, so I'll stop there. We are going to review again tomorrow, and then we will test on Thursday. Okay. All right, so we review tomorrow, test on Thursday. So I would strongly suggest, and your 9-5 homework's due Wednesday, I would strongly suggest that you look over that review sheet and come